And good evening, everyone, or good morning, depending where in the world you are joining us from right now. We certainly welcome you to this month's Vanderbilt University School of Engineering Graduate Program Conversation Hour. For this month's episode, we are very happy to have several student ambassadors from the Department of Chemical and Biomolecular Engineering here at Vanderbilt. My name is Gabriel Luis, so I am the Director of Graduate Recruitment for our School of Engineering. I will be hosting tonight's session with our student ambassadors, with our guest panelists. So without further ado, I want to make sure that each and every one of you have a chance to do a brief introduction for the students and for the attendees listening tonight. So what I'll do is I'm just going to call on you, and if you can just tell me, you can just tell everybody your name, tell us about go ahead and just give us like a fun fact about yourself if you want. I'll leave that optional, but just tell us, what's your main research area and then your current degree program. That would be great. So let's go ahead and start with Kevin.
Hi, everyone. I'm Kevin Korn. I'm a fourth year graduate student in Marjan Rafat's lab, where we look at the mechanisms that lead to breast cancer recurrence after various treatment regimens. And a fun fact about me is, I guess before I came to Vanderbilt and back when I was an undergrad, I used to do voiceover work for anime TV shows. So something completely different from chemical engineering, but anyway.
Gabrielle, are you there? I think you might have froze.
Oh no.
Oops. Well, I can go next. Hi, I'm Josh Basantino. I'm a fifth year, also in chemical engineering, obviously. I work with Dr. King Jennings. He's the department chair of chemical engineering, and my specific work is on using photosynthetic proteins for solar energy conversion. So we basically just take a protein from plants, and then we use it to either make a solar cell. We're using it to try and make useful products, other chemicals, things like that. So I'm really excited about that research that we're doing. And a fun fact about me is I have a 15-pound tabby cat named Yoshi, and he's a sweetheart.
All right, I can go. I'm Chloe Frame. I am a third year graduate student in chemical engineering, and I work for Professor Claire McCabe, and so I do computational research. The primary focus of my work is on doing molecular dynamics simulations from a multi-scale perspective, atomistic and coarse grain simulations of skin lipids. So understanding healthy skin versus diseased skin with like atopic dermatitis, which is like psoriasis. And a fun fact about me, similar to Josh, I can kind of outdo you on the cat scale though. I have two cats. One is Martin, and the other one is named George. George is 22. Okay. Javier, do you want to go?
Yeah, I'll continue. So my name is Javier Gomez. I'm a fourth-ish year student at Jamie Young's lab. What I do is pretty much computational research, but more applied into the metabolomics sphere. So yeah, I pretty much do software development for very advanced tools that don't have software available. Fun fact about me, I don't know. I have bounced between multiple areas of chemical engineering. I have been in biomedical research. I have been in the oil research. I have been also in the food industry research, and I ended up just working in computational stuff. So,
yeah. You guys can hear me, right? Okay, great. I'm Lucinda Pastora. I'm a fourth year as well, and I am in John Wilson's lab in chemical engineering. And a fun fact about me, I guess there are a lot of cat fun facts, so I'll add on top. I recently adopted a new cat. I used to have one, but then I was walking home from lab one day. It was maybe 7-8 p.m. and I heard this tiny little meowing. And so now I have a second cat. And yeah, he's about 6 months old now, so this is relatively recent. But yeah, proud new cat owner and old cat owner.
I do promise there are dog owners in the program as well.
Yeah.
We're not all just cat people.
All right. Well, wonderful. Thank you all for those introductions. I was having a little bit of issues with my internet, but can everybody hear me now?
No. Yes.
Okay. And did everybody go? Was everybody able to do an intro? Okay, good. All right. Internet should be fine now, so we should be good to go. So apologies about that. All right, so let's go with our first question. So many of the listeners tonight, they're really interested about. All right, so what is it about Vanderbilt that stands out when it comes to chemical engineering, and why did you decide, first of all, to go to graduate school? What were some of those reasons, and then why did you decide to choose Vanderbilt? So let's see, we'll have Chloe, if you would like to begin, and then from there we'll just go and have everybody kind of give their take on that. Okay, let's see. I'm not sure if there may be some audio stuff going on. So actually, Joshua, would you like to begin?
Yeah, so I can start. So I originally graduated from Auburn University in Alabama, so a fellow SEC school. And the way that I really got connected to Vanderbilt was I went to an AICHE, the American Institute of Chemical Engineering. I went to one of the professional conferences, and there I found the Vanderbilt graduate recruiting table, and I talked to some of the recruiters that were there. So the recruiters are usually faculty from the program. And that day it was King Jennings was running the table, and I told him, "Hey, I'm Josh. I'm interested in coming to graduate school. Can you tell me something about what you're doing?" And at that moment, we really formed a really strong bond. And so I knew that he was a really good person and somebody that I could see myself working with and getting along with in the future. And then he told me about his research, and that was the point I decided, I love the research you're doing. Vanderbilt's awesome. It's still close to home. It's an SEC school. And that's really what kind of pushed me into going to graduate school. And another thing is that I was at a career fair one time, and I wasn't sure if I wanted to go into industry or go into graduate school. And while there, I met somebody, and he said, not everybody can do graduate school. If school is something that you're good at, if research is something that you're good at, and you like it, you should definitely do it, because not everybody can do it. So that was sort of one of my things. I was like, yeah, I like school. I can do school for a little bit longer. And now I'm here. Also, one really nice thing about Vanderbilt is we have the graduate student council over all graduate students. And we have this really lovely graduate student lounge that has a nice fireplace. It is a really nice place to come and chill out and relax. So definitely one of the good perks about coming to Vanderbilt.
Yeah, yes. I can jump in next. Just to kind of second Josh, I'm also involved with the Graduate Student Council. And I can confirm it's just a great community that we're a part of here, where we get to connect with other students from different disciplines. It's really great to have a different perspective besides chemical engineering all day, every day. So a little bit about myself. I, kind of similar to Josh, I also came from an SEC school. I came from the University of Tennessee. I spent most of my life growing up in East Tennessee, so I always knew about Vanderbilt being an amazing school, and everybody wants to go there, and they're just like, it's the place to be. And so when it became time for me, looking at graduate schools, I looked all over across the country, but for me, when I visited Vanderbilt, it felt like such a great community, and it just felt like home. So it was kind of a no-brainer for me when it came to Vanderbilt. I loved the smallness of a department that we have. It's not a huge department, and it's not competitive, and that it's dog eat dog out there. So I just really, really liked the
All right, who would like to go next?
I guess I can chime in next. So for me, I went to undergrad at University of Texas in Austin, and then worked in the Houston area, actually, at a petrochemical company for about 8 years, and then decided to come back to school. And my goal with going to grad school was I wanted to become a professor. So going to graduate school was obviously the like very clear next step for me. And I wanted to switch industries in a way, I guess. Being in petrochemicals, I wanted to do more biomedical type research. So Vanderbilt was clearly a very obvious choice because of the Vanderbilt University Medical Center and all of the great biomedical research that goes on within the chemie department, as well across like collaborations with the medical center, with biomedical engineering, et cetera. And then also seeing, I guess, for Marjan Rafat, my advisor, she was starting up a new lab here at Vanderbilt at the time, and with me wanting to become a professor, I saw that as a great opportunity to learn about the process of starting up a new lab and getting to see all of that, to make sure that's really what I wanted to do. And then just like meeting with her and seeing how supportive she was with like our career paths and mentoring us and getting us to where we needed to be. I just knew that it was the perfect fit. So that was kind of my journey to Vanderbilt.
I can go next, I guess. So I went to, or when I was an undergrad, I wasn't exactly sure what I wanted to do next. But I did do some research with a professor my senior year, and it was a lot of like nanoparticle formulation stuff. And I thought that was really, really cool. And so this made me think that maybe I wanted to do something in like the biotech drug delivery space, something with biomaterials, something that would have an impact on human health. And so when I started talking to like other alumni and things, a lot of them, and also people who worked in companies like that, a lot of them mentioned that if you want to be kind of a decision maker in the R&D, like research and development space in these kinds of companies, oftentimes it's very beneficial to have an advanced degree. So that was when I started thinking, oh, maybe I should go to grad school, stuff like that. What drew me to Vanderbilt specifically was actually my boyfriend went to Vanderbilt for undergrad, so I had visited campus a few times, and that kind of put it on my radar. Actually, one of his best friends was in the chemical engineering department. And so since I was also doing chemical engineering in undergrad, this made me like a little curious about the department. And the more I looked into it independently, the more I really liked what I saw. For one, the size, like Chloe mentioned, I do think it's a nice size. It's not too big, but it's also not too small. And we have some really impactful research going on here. I liked multiple professors. I could really see myself working for multiple professors. So I knew that there would be a place for me regardless of like who had openings kind of. I also wanted something that had really good facilities for material science and nanotech research. So we have the Vanderbilt Institute for Nanoscale Science and Engineering here on campus. So there are a lot of like common facilities and core facilities and imaging technology that's really relevant that we all have access to as students. And then finally, I was really excited that the Vanderbilt University Medical Center is like right next to us, because that means that we have the opportunity to collaborate with some of those really brilliant people at VUMC. Our research can be a little bit more translatable. We have the opportunity to work with patient samples. So it was really just, a lot of things that were all very exciting. And then, sorry, I know I'm kind of being a little long-winded here, but the last thing, when I visited campus for recruitment, and I really saw like how the department had such a good sense of community, which is not something I had seen at very many other places. That was really kind of the final thing that helped sway my decision as to why to come to Vanderbilt specifically.
I'll wrap up then. For me, it was a very similar experience to Kevin's. I've also wanted to be a professor for a while, and I actually had the opportunity to be an adjunct professor in Bogota, where I did my undergrad from. So at some point, I got the choice of, well, maybe the choice, I had the obligation of either going for a PhD or just looking for something else. So yeah, that's pretty much the reason why I went to grad school. Why Vanderbilt specifically? I think that there were two things involved. One, we had some collaboration with professors from the medical engineering department, and every single collaboration, every single project was awesome. And I realized that the science that was being done here was incredible. So that always caught my attention. And then, thanks to one of those professors, I got to meet the chair of the department in the chemical and biomolecular engineering department. And then I realized how close the research that was being done here was to what I wanted to do. So, as I mentioned, I had a lot of experience in multiple fields, but I had no idea what I wanted to do specifically. Then I realized that here there are a lot of professors that are working on multiple very varied things. So I thought that it was going to be a good opportunity to decide or to find my path, I guess.
All right, wonderful. Thank you so much for sharing that information about the initial reasons of why Vanderbilt and why graduate school. So before I go to the next question, just wanted to give all of our viewers just a heads up. So you'll notice that there'll be a link that's going to go out depending on which social media platform you're using. You should be able to receive a link that will send out, which is a registration link for tonight's event. So in other words, once you register in our system, my office, graduate recruiting office here in engineering, will be able to follow up with you following today's session. So, so if you're interested in wanting to connect with us and to follow up with the discussion and to talk, after today's event, please feel free to fill out that registration that you'll receive. You'll either get it in a link or it'll be a QR code. You'll have both formats to choose from to register. I just wanted to jump in real quick and just say that. Also, we are able, for all the viewers out there, we are able to view your questions. So at any time of today's event, if you have any questions that you want us to answer, and we'll try to get to as many questions as we can tonight, and feel free to just type them in the chat box, click send, and we should be able to receive those as well. So we'll be able to answer those questions for you, as many as possible. So for the next question, I would like to have each of you talk a little bit about what was it about, or I guess do you have any tips or advice that you can give prospective students when it comes to the application process to graduate school? What are some things that you would suggest? So we'll go ahead and I'll just kind of leave it like that, and whoever wants to start, feel free to jump in, and then we'll kind of go around the table and have everybody contribute.
I can start with this one. So I came into graduate school with an NSF graduate research fellowship because I was able to really use a lot of the resources at my undergrad. So a lot of universities, colleges have some sort of writing center or some sort of prestigious scholarship committee that can help students really write and sort of perfect their essays. And I worked for so long on all of these essays. And after I was able to do the NSF fellowship, I was able to use what I used for that application as a lot of my materials when I applied to grad school, such as like a personal statement and things like that. But I worked for like weeks with our writing studio to really hone in on how to make a good application for graduate school. So that would be one of my biggest advices: is look for the resources you have on campus and definitely take the time to make a good personal statement and application.
Sure, I'll hop in next. So I would say some of the things that made you stand out in application, I would be really explicit about, kind of what you want to do and how that's impactful, not just for yourself, but for Vanderbilt and for like the science going forward. I think, you know, kind of bringing your own ideas to the table is extremely impressive to anybody looking at your application to think, oh, wow, they're really like, you know, they don't see what's available. They could actually build on things. So I just think really going out there and researching explicitly, like who is in the department that you would be interested in working for, what kind of research do they do, and how you can fit into their lab. But I'd also say get involved, like your life. I mean, for me personally, I don't, research is not my life. I love getting involved other ways. If it's in my community, it's at university. So being a diverse applicant is also a really, really fantastic thing to write about. In undergrad, I worked several jobs during undergrad, and you know, it shows that you can balance a workload and still do school. So also touching on, like, you know, things that, you know, changed you during your undergrad is also important to highlight in your application.
I guess I don't necessarily have anything different to say about. I agree completely with Josh and Chloe. I think when I applied, like when I was applying, I really kind of had no idea how to put together a grad application. Coming from industry, it didn't seem like many people left industry to come back to graduate school. So for me, what was really important was my personal statement and telling the story of what's taking me back to graduate school, and going through how kind of my different background could be a benefit in a research setting. And then, you know, mirroring what Chloe said, you know, what professors at Vanderbilt, what research at Vanderbilt was I really interested in, and why would that research really help me get to where I want to go next? And so kind of having a clear idea, even if it, you know, plans can change, your interests can change, but starting off with a clear plan as to like what you want to do next and how Vanderbilt or whatever school, what research you're interested in is going to help you get there. I think like spelling that out in the personal statement and then showing what your strengths are as it relates to that is really going to be key. And it helps the people who are reviewing your application see you as an individual applicant instead of just like a GPA or something like that. It really personalizes who you are, and so they can see how they might work with you as well as you work with them.
I'll take the stand. There's nothing much left that I can say, but I would definitely highlight what Kevin and Chloe said. I definitely agree that one of the, at least from my standpoint, what I think is one of the most important things that you can show in your application is what you are beyond just an engineer. So get involved into I don't know, student organizations or even organization from outside. I think, at least from my perspective as a former professor, I used to value a lot from my students the fact that some of them were involved in student chapters or even, I don't know, sport teams, I don't know, stuff like that. I think that gives the impression of you being capable of managing your time. And again, I would just highlight the fact that being more than just an engineer, more than a GPA, a number, it's very, very important.
And I also, I don't know if anyone mentioned this explicitly, but if there is someone that you're interested in working for, it can be helpful to reach out to them, like reach out to the professor even before you've applied. You know, maybe ask if they can set up a Zoom meeting with you, just chat about your research, chat about if they have space and if they're looking for a new student, that sort of thing. I also think it's helpful to have research on your resume because even though we're graduate students, like really what we're doing day to day is we're being graduate researchers, right? So having a little bit of research experience under your belt so you kind of know what you're getting into, maybe you know what general space you want to work in, And then, yeah, trying to like cultivate those relationships both with your undergrad advisors, I think, and then also, you know, reaching out to potential new advisors, the new professor you might want to work for in graduate school. I think both of those things will really, you know, help strengthen a graduate application.
Yes, no, I think those are excellent points that you made. And going and transitioning to the next question. So on that same note, what tell us in more depth about the research that each one of you do, because I mean, obviously everybody's focused in a slightly different area, but kind of talk to us a little bit more about what is it about the research that you do, and then the opportunities that exist, not only just within chemical engineering, but just kind of Vanderbilt as a whole when it comes to being able to do interdisciplinary research, being able to reach across campus, having that kind of small campus feel where you are able to get to know your faculty intimately, as well as, you know, your other lab mates, and being able to work cross-discipline. And how does that kind of work and represent itself in your everyday life when it comes to the research, the very research that you do? And also feel free to mention, you know, different, you know, research centers and institutes that you collaborate with as well.
I guess I can tackle first. My specific research, I mean, so in our lab in general, we're looking at cancer, recurrence, and metastasis. And there are several students in our lab that are specifically looking at breast cancer, and I guess radiation therapy is one of the ways to treat breast cancer. But there obviously can be some negative side effects of radiation therapy, and so we're trying to understand some of those molecular mechanisms that can lead to failure of treatment and eventually relapse and recurrence. And in our lab, we look at that through in vitro models, through three-dimensional models, looking at hydrogels, spheroids, organoids, to study radiation response, and how different cell types within breast tissue respond to radiation therapy, and then how immune cells interplay with all of that. And then we also do work in vivo. So we utilize mouse models to understand kind of more complex relationships in a more biologically relevant setting, to further understand those mechanisms and figure out ways, based on what we've done in vitro, can we do something then to prevent that recurrence in vivo within the mouse models. So kind of thinking very translationally, like how could this eventually help improve radiation therapy treatment for actual patients. And so, I mean, with that, like my specific project looks at like metabolic responses to radiation therapy, and then how obesity comes into play with all of these things. And we're able to collaborate with researchers in the medical center. So specifically, like I have collaborated with Alyssa Hasty's lab, who's their lab's like a pioneer for immunometabolism research. So I'm able to learn new techniques and get involved in vivo studies with their lab, and like that came about through a training grant that was available to me through Vanderbilt. So we could have, there are opportunities to kind of get that sort of cross department training sponsored for you by these various training grants and things like that. And then from there are so many different core facilities that you can get involved with to try new techniques and experiments. Lucinda was also involved in that training grant and also has worked with Alyssa Hasty's lab. So can pass it to you if you want to talk about your experiences there as well.
Sorry, I was muted. Yeah, sure. I can talk a little bit about that. Well, just to talk about my research first, I mentioned I was in John Wilson's lab. So we call ourselves an immunoengineering lab, even though we're in chemical engineering. So basically what that means is that we're going to like engineer materials to modulate the immune system or to deliver like agents, whether that be like a nucleic acid, a small molecule drug, whatever. To modulate immune responses. So whether that's in like a cancer application where you want to turn crank up the immune system so that you can have like an inflammatory response and help mount an immune response against the cancer. Or on the other side of the coin, if you want to tamp down the immune system in cases of like inflammatory diseases and stuff like that. So I work on the inflammatory disease side of that. So basically, my project is to like deliver these small molecule immune inhibitors to try and shut down this certain pathway called the CGAS-STING pathway. It's involved in the innate immune system. And so this has been implicated in a lot of diseases, including like fatty liver disease and like NASH, colitis, sepsis, macular degeneration, just aging. It's like showing up all over the place more and more as the field is developing. So I'm trying to, choose one of these model diseases and deliver the inhibitors to try and shut down the inflammation and improve disease outcomes, whether that's remission in the case of colitis or, halting, at the very least, halting disease progression in something like NASH. So, so I mentioned a few different things, right? We have the polymer side where we're making the materials. We have the formulation side. A lot of us work with, we formulate the polymers into particles or hydrogels or things like that. So I mentioned the bins, right? And then once you have your particle or your pro-drug or whatever you're working with, then you have to test it, right? So we do a lot of in vitro work. So some people will do assays using the high throughput core, for example. And there are a lot of in vitro assays will use the molecular biology core to run things like PCR and different assays. And then also we're interested specifically on how it affects the immune system, right? So we have a lot of collaborators in the medical center and the Department of Immunology and a few other departments as well. So I've also noticed that, and maybe I've just had a particularly good experience, but usually people at Vanderbilt seem very willing to help you. If you send them an email about working out an assay or starting a new collaboration, usually people are very receptive, and even if they themselves can't help you, they're able to point you to someone who can. So I do really appreciate the collaborative environment. I appreciate that there are different, whether it's biology, immunology, materials, there are resources there that we can utilize. And I mentioned earlier patient samples, for some of the tumor projects, we'll have people get patient samples from people's real tumors that we can then test our agents in a real tumor, right? Of course, ex vivo, not in the person, but yeah, it's just been, we've had a wealth of resources and it's very interdisciplinary, exciting work. I think Vanderbilt's the perfect place for it.
I'm going to follow that up. So what I do is, I think it's easier if I start explaining what my lab does. So what my lab does is to analyze the metabolism of different organisms. We're trying to understand what's going on inside them. We have projects with diabetes. We have projects with CHO cells. We have projects with algae. But the catch is, whenever we try to understand what's going on, we need to use a technology that's called mass spectrometry. Pretty much to measure the chemical compounds that participate in the metabolism. But the thing is, we have realized that most of the software that's available, either publicly or paid software that's out there, cannot handle the level of complexity that the latest advances in the technology have given us. So what I'm doing is I'm developing computational tools to analyze those experiments and the experiments that we do with mass spectrometry of high resolution. And in order to test that, we have multiple collaborations with internal and external laboratories. So we also have patients, or we also have experiments that have been performed in patients with cancer. So having the medical center close by to get the samples from, fresh samples, fresh cells. It's incredible. There's a lot of people in the medical center researching about diabetes. So we also have a constant flux of cells and data to play with. So that part is amazing.
Okay, I can go next. Like I said, I work for Professor Claire McCabe in computational work. So the way our group operates is we kind of have a super group with another computational group, Peter Cummings, and the two are like, the top of the name in terms of molecular dynamics world. So it's a really great group to be a part of because we just, all these graduate students together, we kind of work on our problems. We all have different projects, but we can bounce ideas off each other, and we all have different expertise in things. So like I said, my project is molecular dynamics of skin lipids. So handy dandy demonstration. If you've heard of CeraVe, they're like really like when you buy lotion and stuff and you have dry hands. CeraVe is like a really great product out there, and CeraVe, it's based off of ceramides. So what I do my research on is ceramides and cholesterol and free fatty acids in order to like restore the skin barrier. And so since we kind of have this multi-scale approach, we're like the computational side, but we also have a collaboration with our experimentalists in the Netherlands at Leiden University with Joke Boustra, who is kind of like the mother of skin research. She's amazing. And basically started skin barrier research. So the collaborations that are available at Vanderbilt, the resources that are available to us. So with our super group that we kind of have, we also have faculty from mechanical engineering and civil engineering housed in the same location with us at the Multiscale Modeling and Simulation Center. We also call it MUMS, where it's just kind of like this hub for computational research, and it's a great place. We also have extensive contracts with Lawrence Berkeley National Lab, Oak Ridge National Lab. We had a lot of time on NERSC, their supercomputers. We also have time at Oak Ridge National Lab on Titan. And we also have our own in-house clusters where we can run our own jobs. And Vanderbilt also has its own supercomputer available to all students. So Vanderbilt, one of the best things about it is it's very well resourced and funded. So you get a lot of opportunities given to yourself. So for instance, with my group, we have this possibility of being able to go to the Netherlands and work with our experimental collaborators. And it's a really cool group to be a part of.
And I can finish up. So I work in Dr. Jennings' group, and big overview, we're a materials group. So we have a pretty wide range of some of the things we work on. I will say that every single one of the projects that a graduate student is working on is a collaboration with somebody else across campus. I know that 2 of our new graduate students are actually starting up a collaboration with Chloe's group, the McCabe group, on being the experimentalist to their computations. So it's really exciting to sort of see that collaboration grow, and I've never seen the computational and experimental thing go side by side. So I'm really excited to see how that works with. And the projects that I work with are mostly based on electrochemistry, and we work really closely with David Cliffel in the Department of Chemistry. He's one of the electrochemistry gods. So we're really excited to work with him. But more specifically on the work that I do, like I said, I work with photosynthetic protein known as photosystem 1, and it is found in all photosynthetic organisms. And right now, plants around the world are able to harvest over 2,000 times more energy than the amount of solar energy that we convert right now with our solar cells. So we definitely have a lot to learn from plants, and plants also make more energy than humans consume by like 3 times the amount that we consume. So if we can harness the energy of plants, we should be able to be in a greener place. It's really one of the greenest research projects that you can be on, because the protein, whenever you extract it, it is what makes plants green. It is just filled with chlorophylls. And we actually use spinach to harvest all of our photosystem 1. And it's really kind of fun because you put the spinach in a blender and it's like you're kind of cooking your cells and making proteins come out. So it's really fun to go through that process, and it's a lot of pretty colors and pretty simple. But once we get the protein out, what it is specifically good at is doing electrochemical redox reactions. So if you remember from your general chemistry, oil rig, Leo Gur, oxidation is a loss of electron, reduction is gaining electron. That is what I do day to day. And it is not something that I knew how to do whenever I came to grad school. So if you don't know exactly a lot about the research or the group that you're going into, don't worry. None of us did. But right now, I would consider myself to be pretty good at electrochemistry. And this protein, photosystem 1, has two sides to it. One side does oxidations and the other does reductions. So it's essentially like a little tiny solar battery where if it gets an electron at the bottom end and then sunlight comes in and hits it, it energizes an electron and makes it go to the positive end. So it's like a little battery with a negative and a positive end. And our job is to find ways to get an electron to the protein and get an excited electron from it. And we can do that to make a solar cell. So if we put all of this protein down on a surface in a liquid and give it a redox mediator that is able to accept and donate electrons, the protein, whenever the light turns on, it'll just do its thing, and we're able to just generate electricity from the protein by itself. And so that's really exciting. And one of the things that we are really moving into is trying to connect molecular wires to the protein. The protein itself is on the tiny nanoscale, so it's like 10 to 20 nanometers big. So it's really hard to sort of get in there and connect tiny nanometer sized wires there. So that's one of the really exciting things that we're working on, trying to figure out how to do that. And we think that if we can do that, we'll be able to really open up avenues for a lot more research for this kind of green photosynthetic research. And another thing about the Jennings group is that we're really fortunate in all of our group meetings. So we meet every week with both Kane, our advisor, and he also has another member of the faculty in chemical engineering, Paul Lipinas. They both come to all of our group meetings. And so every week we'll have somebody present the research, the work that they're doing. And we'll have two PIs who are able to sort of, PI principal investigators that are able to sort of talk about things to make the research better, help answer questions. And then the group can also join in and talk about sort of ideas and things like that. So it is a very collaborative group. And I really just enjoy working with the Jennings lab.
That is fascinating. It's just really neat to hear all the different niche areas of research that are going on in chemical engineering. And yeah, I mean, we could just make an entire extra hour session just to talk about everybody's research and to go into more detail. But thank you for providing those brief introductions. Next question I want to ask everybody is, so tell us a little bit more about, what is like the typical, what is like a typical day in the life of a graduate student in engineering at Vanderbilt? So like kind of in addition to doing research, kind of, what other resources are available on campus that you like to utilize? Will there be student organizations or graduate student services? What are some things that, graduate student council, that's something I know that Joshua is also involved in that he'll probably talk about as well. But yeah, so in other words, like what are those resources and kind of what does your day-to-day life look like when it comes to that?
I guess I can go ahead and jump in. So like Gabriel said, I work with the Graduate Student Council. I'm the president of the Graduate Student Council at Vanderbilt. And so that's essentially the graduate student government. And so we do a lot of work to provide events for all of the graduate students to come and attend. And we also take questions if graduate students have concerns about ways that they think that the entire graduate student experience at Vanderbilt can be improved. They can come to us, and we have a relationship with the administration. And so we're able to talk with them and work on a lot of solutions to all these problems. And we have really fun socials. So we have 4 big social events every year, and we have over like 500 students come to these. And so it's really one of the fun times to get all of the graduate students together and do one big thing. And so definitely if you come to Vanderbilt, take part in the events that the GSC puts on, because we do a lot of these events to really help our graduate students. I'm also involved with the fencing club at Vanderbilt. So I'm actually one of the captains of the fencing team. It's something that I started whenever I became a graduate student at Vanderbilt. I had never fenced before, but it's something that I always really wanted to do. And so I was like, I'm just going to do it. So I've been doing that for 5 years now, and that's honestly been a blast. So definitely graduate school is a time to sort of branch out and try new things that you've never done before and really learn about yourself. And then the other group that I'm also a big part of is the Engineers Without Borders group at Vanderbilt. It's something that I worked on in undergrad, and I was able to sort of take the skills and experiences that I learned from that and help build the Vanderbilt chapter. And it's really fun working with the students on really designing these projects that are engineering service projects that are going to make a difference in towns across the world. And I think that's it for me.
Yeah, just to build off what Josh said, I have always enjoyed service in the past, but it wasn't until I came to Vanderbilt that I really enjoyed just advocacy in general. So I'm pretty involved on campus with, for instance, Vanderbilt students for science education. So I recently just finished this up where we go to a local middle school and we do like little science experiments with 6th graders, and that was awesome. So that was one of my day-to-day things, was teaching like conduction and convection to 6th graders. It was cute. But other things, like I am involved with the Graduate Leadership Institute at Vanderbilt. They regularly have seminars and workshops on how to build your portfolio and how to gain skills for life after graduate school. And so for me, I've attended a lot of events, for instance, with like AAAS in terms of maybe doing policy or advocacy after my time here. Like Josh said, I'm also involved in the Graduate Student Council. I'm the Student Life Liaison. And so that's kind of how I fell into this role for advocacy. I've thoroughly enjoyed, when students need help, helping them, point them to the resources, because Vanderbilt just has a plethora of resources. And showing these students these resources is just, it's amazing what Vanderbilt has. They have like these academic life coaches. They have fantastic student health. Mental health resources are heavily prioritized. The Career Center is fantastic. So I love being involved on campus. It's kind of thanks to Josh for, publicizing that in the Kimmy sense. That's how I got involved, was seeing what kind of he did. As far as fun things around Vanderbilt, I'm a huge sports fan. We're SEC school. So I love the So for instance, the Chemical Engineering Graduate Student Association, we have our own graduate student association. And this weekend, we're going to the Titans game. So we get discounted tickets so we can go to football games. Like I've gone to hockey games with the Predators. Those are really fun. And more on a Vanderbilt scale, I was in a cornhole tournament for Vanderbilt. It was intramural. So there's just so many ways you can get involved on campus, different outlets, and Nashville's a great place. Yeah.
I might follow that up. So I have been involved in a couple of organizations inside Vanderbilt and some others outside Vanderbilt. So inside Vanderbilt, I was part of ALAS, which is the Association of Latin American Students. It was pretty fun because they were focused on, I guess, showing the cultural differences between multiple Latin American countries, and actually was part of one of the events that they held, which was a kind of show where they showed the typical dances of all of the Latin American countries. I'm from Colombia, so of course I had to go with salsa there. So that was pretty fun. I'm also involved into a couple of sports teams. I used to play before COVID with a volleyball team. We went to a couple of tournaments. We were pretty good, and then COVID happened and I stopped going. But now I am with the squash team. We had a tournament a couple of weeks ago, and we're going to have another tournament in 2 weeks. So having that sense of community with not only people from inside the department or other graduate students, but also having the opportunity to, share some time with undergrads and like sharing those experiences is always awesome. Now, outside Vandy, Nashville offers a lot of volunteering organizations. If somebody's interested in that, so I am part of one in Nashville that tries to help students, pretty much high school students that were affected by the pandemic, where some of the classes stopped, and just to prevent them from stopping their learning processes. We just chimed in and helped them with their homeworks, or if they have specific doubts or preparing online exams or something like that. I was part of that. And outside Nashville, I'm also part of an organization that was founded by one of my best friends that helps kids from other countries to learn new languages. And how that works is we just gather in Zoom or in Discord, and we start playing games, video games, but we always talk in a different language. So we do that in Spanish, we do it in English, in French, and I also had the opportunity to learn a little bit of German just thanks to that. So those are really extracurricular things that I've been doing while I'm a grad student.
I can talk a little bit. So day to day, right? Obviously, you're gonna get to lab, do some research, read some papers, maybe attend some group meetings. But after, or maybe during, I don't know. We like Chloe said, there are a lot of opportunities for service. That's one thing that I've really enjoyed doing here. So I was also in the Vanderbilt Student Volunteers for Science for a few years. So I really enjoyed going out into like Nashville middle school classrooms, teaching science lessons. It's in a lot of cases, it's schools that don't necessarily have the resources to do those kinds of hands-on demonstrations. So it's really nice to be a part of like educating the next generation. I was also involved with VINS, I keep mentioning VINS, but the Vanderbilt Institute for Nanoscale Science and Engineering also has an outreach program. So essentially this one's geared more towards rural schools. So they'll bus in high school students from more rural counties in Middle Tennessee, and you basically show them how to make solar cells from blackberries. It's actually really, really cool. And then they can image it on like a TEM or an SEM. You can answer questions about college and things like that. So I've really enjoyed that. Also, this semester, I'm taking an art class through the Surratt Art Studio for the first time. Every year, we get or every semester really, we get emails about these different art class offerings. So I took jewelry making this semester with Nancy Rourke. She was great. I highly recommend if you need a creative outlet. And then, another thing that I didn't hear anyone mention is that we, as graduate students, we get membership to the Vanderbilt Recreation and Wellness Center. And so I feel like that's critical, right, for staying active and keeping a healthy work-life balance. The gym it's a really good gym. There's a bunch of equipment. There's a powerlifting room if that's what you're into. Basketball courts, badminton courts, an indoor track. There's also an outdoor track, beach volleyball court, all sorts of things. And related to that, we also get free classes, at the gym, so a Zumba class or a yoga class. And they're offered at various points throughout the day. So if you want to go in for morning yoga at 7 a.m. before you get to lab, or if you want to do an evening workout class, or a lifting class or whatever. We have access to all of those. And of course, intramurals are also fun. So I've done dodgeball. I like the sports with a lower barrier to entry. So dodgeball, right? I'm trying to think if there's anything else. I also just feel like there's always something going around on campus. So we get these emails that will be kind of a week at a glance, or things you should know going around campus, or our graduate student council will send us, newsletters of different events, whether that's like a seminar, like a personal finance for PhDs, or negotiation workshop, or all these other workshops that are really helpful in more than just your academic life, but in life as an adult in general. Or fun events also. So like the GSE just had a Halloween party recently that was really fun, and a nice change of pace, a nice thing to kind of relax a little bit, a break from work. But yeah, there's all sorts of things going on campus, all sorts of clubs you can join. Yeah, so there's definitely a lot of opportunity for that work-life balance.
I don't know how much I can add to all these great activities. I guess one great thing with Vanderbilt is its kind of central location within Nashville. You're so close. I mean, half the time within walking distance to so many great restaurants and parks and bars, whatever you want to do. There's just great. There's so many great activities just right outside of Vanderbilt. So going, grabbing some, going for happy hour with your lab or something like that is like a common activity, just to get together and chat outside of the lab. And I think like a lot of labs develop their own little mini community and love to like hang out with each other. I mean, like our lab, we'll get together. I host like game nights for us. So, we'll get together, play some board games, get really competitive with Settlers of Catan, and stuff like that. And like for me too, like my blowing off steam is going and exploring like restaurants and the kind of vibrant food culture that's here in Nashville, which kind of continues to grow, which is great. There's always new restaurants to try out. And I guess a little bit on the day-to-day life, like our program, when you join the program, you'll start off and typically you're taking classes, you're getting involved in research, and then you'll also be a teaching assistant. So kind of at the beginning, your day-to-day life will look different than it does a couple of years in when your focus shifts more to research. But I think that what's great about our program is the opportunity to get to TA and to get to teach if that's something that you're interested in, or to learn whether or not you're interested in. But it's also not something that takes up so much of your time that you're not unable to get involved into research. So definitely your day-to-day changes from first to third year, and then eventually as you're later in your time in grad school, you're doing research and you're kind of working at like a job, depending on what experiments you need to do, what stuff is going on. For some of the biological research, you can sometimes be at the will of your cell lines, and when they need things, they need to be fed, or when mice need to be taken care of. But there's also a lot of flexibility too, because if you have to kind of adjust your schedule for that, for what you need to do for work, then you can also adjust it for your personal life as well. So I find it's just like a great way to kind of like balance that like work-life balance sort of thing. So yeah, that's my 2 cents on that.
All right, wonderful. Thank you so much for your input. So I see we have 2 minutes left before today's session concludes, but I think I'll be able to fit one more question in. So I guess just in the interest of time, we'll try to keep the next question. I guess for each person, we'll try to give everybody about 30 seconds each to answer the questions. This is like a speed round right now. So kind of gather your thoughts. Here's the question. So what are your plans for after graduation? So I know that, especially since you're all PhD students, and just by the way, for our viewers, for chemical engineering, we do also have a master's program as well. But for today's session, we're focusing on the PhD program. So when it comes to your idea of, okay, like, what do you want to do professionally? Many PhD students, some may go into academia, others may go into government agencies, or some may go into industry. So there's quite a bit of variety when it comes to the different options that you have available when it comes to what you want to do. So yeah, what are you thinking about doing? And feel free just to jump in and begin, whoever would like to go first.
So I can go first on this, because actually this morning I had an interview with the professor because I'm applying for postdoc position. And so I talked to her about sort of the skills that I have and what things that I can learn, because I think I want to go the academia route. So I've been looking for postdocs. I went to a conference last week and was able to network with a lot of people. And I really enjoyed sort of the process of learning this out.
I likewise, like Josh, am interested in. I wanted to come to grad school to be a professor, and I still would like to do that. So yeah. So my plans next will be also to apply for a postdoctoral research position, and then hopefully one day become a faculty member to both teach and to lead a research lab.
So I'll hop in after Kevin. I came into grad school wanting to be a professor, and I changed my mind. So it's okay to change your mind. It changes frequently. So for me, finding the JUSE, I am loving advocacy. I had no idea that, like, with a PhD, I could go and work in policy or work and go that route, go to Capitol Hill and stuff. So I'm also interested in doing like an R&D kind of route, but also I'm a weird PhD, right? So I'm a computational person. I have these resources in chemical engineering. So I also have the data scientist route. So the beauty of kind of my position is the world is your oyster. So.
I came in, right, thinking that I would go into like biotech, maybe doing like nanoparticle formulation, drug delivery stuff, and I'm still very much open to that. I also have been considering, I mean, maybe I could go work for the FDA when I'm done. I'm still pretty undecided, you know. I'm definitely open to it. I do think I am probably not going to stay in academia. I think it's much more likely that I'll end up either going the industry route or maybe even working for the government. But yeah, I'm not really sure.
For me, I think I have the same issue, or well, not issue, but I'm in the same position as Chloe. I came with the idea of developing a career in academia, but at this point, I know that I want to do research, and most likely I will end up either in a private company that does research, or even in academia, working solely as a researcher. But yeah, the part of me teaching and that side of me, I think, has been outpaced by other passions, I guess. But yeah, I'll do research. I don't know how or when or when. Yeah, that's what I want to do.
All right, wonderful. Well, thank you very much for your terrific insight and for joining us tonight on the panel. We're going to have to leave it at that for tonight. We have gone a little over time, which means that just means we were just having a lot of fun tonight, and we just kind of, time flies. So what we will do is, for any listeners out there who have been able to, we had the link sent out so you can go ahead and register. We'll follow up with you. If you have any questions along the way, we'll definitely be in contact. And just wanted to say thank you again to the panelists for your time this evening. I personally had a great time, and this was a lot of fun and very informative for the students that were listening, for the attendees. So thank you again. Great panel tonight, great conversation. We could have easily added another hour to tonight's session, but for right now, we'll keep it as is, and we will, we'll definitely all be, in contact. Stay safe out there. Have a good evening. Thank you again. All right.